They can see me?
I hope so.
Okay, hi. Sorry, we're having some problems with the camera, so we're a little late.
I need some feedback.
But this is interactive. It's a review class for test number 2.
Why don't we see if anybody's actually listening first? Get some feedback from them on Google. Ask them to text you on Google Hangouts or on YouTube comments.
If you guys are here, you can either contact me on Google Hangouts with a question or on YouTube with a question. One or the other, and we'll see it up here. So maybe somebody, if you're out there, maybe somebody should ask me a question like, where are you, Dr. Mirabile? So this way I know somebody's out there. If nobody's out there, then this becomes a non-interactive review class. That's all.
That's it.
It will be recorded, and you can actually see it, even if you don't attend it real time. Okay, so I'm assuming that maybe nobody's there, but I'm going to go ahead with this anyway. Oh my goodness. Just too much crap here. Okay, we're going to go over some questions that are like questions on the exam. So this is QBUS110, test number 2, review class. And today, I believe, is the 14th. And you will expect to get this test by tonight, and it will be due Saturday, the 18th, by 5 o'clock. All right, so we're going to start with this problem here. Let's say y equals 3x squared plus let's start with this one first. Sorry, that's not my okay. So we're gonna do what I think is 2x squared.
There are a couple of people watching at least.
Plus 5 x squared y to the 4th minus 2y squared minus 10 equals 0. You want to find dy dx. Okay? So let's find dy dx of each term. So dy dx of 2x squared plus dy dx of this multiplication term minus dy dx of 2y squared minus ddx of 10 equals 0. Now you can see we can do this. You see you have an x here and an x here, which means you're taking derivative of a function with x in it. That's like we've been doing for such a long time. I'm sorry, maybe you can't see this. I see this is different. How do I stay away from this board? Can they see the?
Well, the camera's right here.
Yeah, okay.
So, yeah, it's kind of hard.
All right.
Well, you're right-handed, so that'll work.
So this is going to be 4x. That's okay. But now this is a product rule. So I have to take the first term times the derivative of the second term, y to the 4th, plus the second term, y to the 4th, times the derivative of 5x squared, minus derivative with respect to x of 2y squared, and the derivative of a constant is 0. So we'll put that on there. Now this I could take x and x, but look what happens here. I have a derivative with respect to x, but I have a y function. That means that I have to use my chain rule. And the way I use my chain rule is I keep the 5x squared. This has to be taken with respect to y. So the first thing I do is I say d dy, y fourth, making this and that compatible. But now, because I've done that, I have to add on a dummy dy dx. Now what that does is basically the dy and the dy cancel, so I haven't done anything, but I've set up what I want to find as a variable. So let's look at the next part of this. Y to the fourth is okay. The derivative of 5x squared with respect to x is fine because I'm taking a derivative of x with respect to a function of x. That's going to be 10x minus the derivative of 2y squared with respect to x. I cannot take. So I have to build a dummy by taking it with respect to its function and then attaching dy dx, whole thing equals 0. So actually dy is canceled, so I haven't added anything, but now dy dx is a variable. All right, let's go through this now. 4x plus 5x squared. Now the derivative of y fourth with respect to y I can do. It's going to be 4y cubed. And don't forget I have to attach this dy dx because I did an implicit there. Here, bring the 10 out. Make this 10x y to the fourth. Now here, I take the derivative with respect to 2y squared with respect to y. That's fine. That becomes 4y. And I still have the appendage on here. So since I want to solve for dy dx, all the terms not in dy dx, I'm going to bring to the right side. I'm going to bring this term to the right side, so they're going to become negative. I think I have to go in front of you here for a minute, but I'll show you what happens. 5x squared times 4y third.
I know it's difficult, but if you can write bigger at all, there's lots of terms here. But
dy dx, okay. Writing bigger, he says. Okay.
Bigger the better.
And that's going to use up a lot of space. But 5x squared, 4y third, dy dx, minus 4y dy dx. Bringing these two terms over, minus 4x minus 10x y to the fourth. Now the idea is to solve for dy dx, and dy dx, because we did it implicitly, becomes a variable. So let's go back up here and take what we did down here and factor out. I will write it over again here. I'm going to multiply the 5 and 20 together. So I'm going to get 20 x squared y to the third dy dx minus 4y
as big as you can do.
Dy dx.
They're having trouble seeing it.
How do you know?
Because they're telling me they're having trouble seeing it.
Okay. How come on the videos?
Oh, that's good. I think that's good. Yeah.
How come on the videos they can see it?
Because I move closer with my phone.
Oh, I see. Okay.
Yeah, that's going to work.
Minus 4y dy dx equals minus 4x minus 10x y to the fourth. Now I'm going to factor out a dy dx. I think I missed a dy dx somewhere here. Yeah, right here I missed a dy dx. Sorry about that. Let me rewrite this over. So I'm over here. 20 x squared y third. I dropped that as I went upstairs. Let's factor out the dy dx. That's going to be 20 x squared y to the third minus 4y equals minus 4x minus 10x y to the fourth.
Let's try something here.
Now, all we have to do is basically, is that easy to see if I go over here now?
I think so. Can you see it better? Because you can see the feedback, right?
Yeah. Just the board here.
I'll just hold this up and use this camera.
Okay.
That way we'll be closer.
All right. So now I'm going to divide both sides by 20 x squared y third.
It's probably better if we switch places because now you have a nice shadow from the light.
So you want me to switch places? Okay.
Yeah.
This is just an experiment here. X squared y third minus 4y. So dy dx now becomes, finally, minus 4x minus 10x y to the fourth over 20 x squared y to the third minus 4x. And that's your answer. This cancels. I notice your solution has x and y in it. So you need x and y to find dy dx. But this is probably the most complicated you'll ever get. But basically, it's implicit. Part of it is implicit. Part of it is irregular. So once again, you can't take the derivative of a function in y with respect to x. You have to change that to dy dy. And that's what we did when we did our dummies here. Okay, so that's number one. I'm trying to give you problems that look like the ones. I'll give you some time to write it down. But I'm trying to give you some problems that look like the ones that are on the test number 2. And let's go with another problem. Okay, let's go with a simple problem here. And that's going to be, let's say this is profit. And that equals minus t cubed plus.
Sorry.
We're doing some rearrangement here. Is the board yeah, I think this is easy to see now, right?
If we go over here, sorry, everybody.
So which way are we doing it? Am I going here and you're going there?
I think this is going to work.
It's going to work right here?
Yeah, hopefully everyone's not getting seasick here as I move around.
Okay. And this is going to be...
let's go with this.
Plus 27t. Okay. Now, what do we want here? First, we want to find dp dt. That's going to be minus 3t squared, just a simple power rule, plus 14t plus 27. That's that. Okay, now what we want to find is inflection points. Inflection points. So what do we have to do for that? Well, we know to get possible inflection points, we need the second derivative.
Dr. Mirabile, if I can just pause for a second. We have a comment asking for you to do number 5 on section 11.5. I don't know if you just want to write a note at the top of the board, maybe, if you're not going to do that one anyway, but that's a request we have.
I'll put them up here. Okay, take the second derivative here. That would be p double prime t is this derivative of the first derivative would be minus 6t plus 14. Now, we're going to set the second derivative equal to 0 to find a possible. We have minus 6t equal minus 14. So t is going to be 14 over 6. So we're going to get 2, right? 12 plus 20. So let's keep it at 23. And we won't bother with the decimals since this is just what I'm doing now. So we have 1 point. Now this is a possible inflection point. Possible inflection point. I should write bigger.
14 over 6 is 23.
14 over 6 is 2.3, right?
Well, yeah.
Yeah, 2.3. I'm sorry.
I see the decimal.
Yeah, 2.3. Sorry, the decimal was hidden.
The decimal was infinitesimal.
Right. Okay. So now, in order to find whether you have to test using the second derivative.
Oh, sorry.
Sign test. So you're going to put 2.3 here. And I would go with a 1 here. And I would go with a 3 here. So let's take the second derivative with respect to 3 and the second derivative with respect to 1. So that would be minus 6 times 3 plus 14 minus 6 times 1 plus 14. So this is minus 18 plus 14 is minus 4, which is less than 0. This is going to be minus 12 plus 14 equals 2, which is greater than 0. Less than 0 puts you at a maximum. So it'll be like this. I'm sorry, that's P double prime 1 is greater than 0. That's going to put you at a minimum. So that's going to look like this, or concave up. That's at 1, where P double prime 1 is greater than 0. Now, P double prime 3 is less than 0. That's going to put you at a maximum, or concave down. This is concave up. Now we go from a smile to a frown. So yes, this is a point of diminishing returns. When we go to a smile, I'm really happy, and all of a sudden my sales go down, I'm sad. So yes, so we can say here, finally, T equals 2.3 is an inflection point and a point of diminishing returns. All right, so you'll have one of those on the exam, definitely. Somebody has asked for 11.5, number 5.
Let me check the comment stream over here.
We're going to check the other comment stream too.
Sorry about that. It's hard to multitask here. I think I have the camera figured out now. Somebody said is the equation supposed to be minus 3t squared plus 24t plus 27. Minus 3t squared plus 20. Right here, this 14. Is it supposed
it
to
is
be
minus t cubed plus 12t squared plus 27t.
Okay.
Minus t cubed plus 12t squared plus 27t.
Right, but then when you take the derivative, 2 times 12 is 24. I think is what she's saying. Sorry, I wasn't paying attention earlier. I was trying to figure out the camera.
All right. Here, instead of changing the whole thing, let's make that a lot easier. Okay, so I'm going to make the nothing changes here now, which is good. So all I did was change this to plus 6t squared. So minus t thirds plus 6t squared plus 27t. That'll give us minus 3t squared plus 12t plus 27. And the rest is right. Take the second derivative. It's minus 6t plus, and that's going to be 12. So it's going to be really nice because this comes out to 2. And nothing's going to change except that this is going to be 2. So we're going to have here 12 here. Minus 18 plus 12 is going to be minus 6, which is still less than 0. Now the problem is coming here is minus 6 plus 12 is going to be 0. So now that gives us a problem, which means that because of this, I have to take something which isn't 1. So I can do, if I want, 1.5.
Is it minus 6 plus 12? 6.
Minus 6 plus 12 is 6. You are right. And that's greater than 0. So that's okay.
All right, everybody. I got the camera figured out. I'm tracking now.
All right, now we're tracking.
This is an ongoing
So you got
experiment.
minus 18 plus 12 is minus 18 plus 12 is minus 6. Minus 6 plus 12 is plus 6. That's greater than 0. Same solution. 3 gives me maximum concave down. 1 gives me a minimum concave up. Smile, frown, still a point of diminishing returns. So instead of t equal 2.3, it's t equal 2. All right, that came out a little bit nicer than the 2.3. I'm glad I changed it to a 6. All right, but anyway, the technique is there. You take the first derivative. If I had asked you to find max min, I would set the first derivative equal to 0. Probably use the quadratic equation and find the t-values. And then I would use the second derivative and substitute those t-values to see if I had a max or a min profit point. I didn't ask for that in this one. I just wanted to find inflection points and the point of diminishing return. Now, somebody asked for 11.5, number 5. Anybody else have any?
I kind of have to go over here to see the comment stream. Let me see.
All right, let me erase this.
You can erase it in the meantime. All right. Is there any difference between an inflection point and a critical point? Is the question.
Yes, and an inflection point. Yeah, a critical point. You set the first derivative equals 0. Okay, that gives you your critical point, and then you investigate for max or min. So you would find a t-value, which is a critical point, and you investigate for max or min. In inflection points, you set the second derivative equal to 0. So if you want to see a graphic of this, I'll give you a difference between inflection points, and this doesn't necessarily have to be this one here, but I might have something like this. What did I do before you get it? Okay. I might have something like this.
That's the original function?
That's any function that I'm giving you. It could be the original function because it is t-thirds. But as you can see here, at this point, we have concave down, and we're going here to concave up. This is your inflection point. It's where the curve changes from concave down to concave up, or vice versa. In this case, concave down is a frown, concave up is a smile. That wouldn't be a point of diminishing returns. But this tells you that an inflection point is where the curve changes from concave down to concave up, or concave up to concave down. Now, here is a critical point. And a critical point is either on a maximum or a minimum point. So let's say this point here was 1, 2. So here, x equals 2 is my inflection point. Let's say this point here is x equal minus 1. X equal minus 1 would be my critical point. In this case, it would be at a minimum. I could have another point like this if I wanted. I could bring this up like this. Okay, I'm making this a more complex curve. Here now is a maximum point. So let's say this is 5. Let's say this is x equals 5. So x equals 5 is also a critical point, but here it's at a maximum. So critical points are at your max or your min. Inflection point is just the point where the curve changes from concave up to concave down. That's the difference. Critical points, you use the first derivative. Inflection points, you use the second derivative. And that's the way, this is a critical point here. Notice at critical points, what are you getting? It's changing here from the slope going up being positive to the slope being negative, first derivative. Here, from the slope being negative to the slope being positive. Here, you're not getting too much with the slope, but you're getting a concave down, concave up. That's your point of inflection. In this case, your point of inflection was x equal 2. Okay, that's the difference between critical and inflection points. Okay, now let's go to the problem 11.55. Let's see what that is. Okay. So this was homework 11.5, number 5. And let's look in your book and see what it is. Okay, correct me if I'm wrong, but number 5 was a, no, well, I'm not in 11.5 yet. Number 5 was PQ plus P equal 5,000. Nope, that's not it. Number 5 was this. I see it. I'm going to erase this now. Hopefully you know the difference between inflection points and critical points now. Critical points are at a max min. Inflection points just show that the curve is changing from concave up to concave down. Critical points, first derivative equals 0. Inflection points, second derivative equals 0.
And you're still holding Hangout office hours, correct?
When?
I'm asking you.
Yes, but tomorrow.
Tomorrow, what time?
11:30 to 3:30.
Google Hangout office hours, 11:30 to 3:30. Tomorrow.
Yes.
15 April.
Q+1. Is this the one? Whoever asked, contact us. Is this the one you wanted?
All right, let me take a look here. Can you hold it for a minute?
Yeah.
Let's see here. 11.5 was the worksheet you sent us through email.
Yes, but I don't have that, so I just want to know if is this the one he's talking about, number 5?
Okay, who asked this one? Bella asked about this. So, Bella, can you give us a comment to confirm this is the correct problem that you're asking for? I don't know. I mean, there's a possibility she's no longer watching. We could just.
Okay.
Somebody else wanted to see it too, though.
Okay. All right. So what do they ask here?
Danielle and Elena also want to see it. Oh, Eliana, actually.
Okay. All right. They're asking to find elasticity when P equals 39. So P equals $39. Q, we don't know. All right. And tell what type of elasticity it is. Now, see, I haven't told you how to find out whether revenue's increased or not. So I'm not going to be interested in that. It's not going to be on the test. But A and B, I am. Okay. So let's change this to P plus 1. Q plus 1 to the 1/2 equals 1,000. Now, I'm looking for the elasticity, which is minus P over Q, dQ, dP. So what do I need? I need P, Q, dQ, dP. I'm only given P. So step 1, find Q. Got to go back into the original equation. Call that 1. And I know P is 39. So it's 39 plus 1. The square root of Q plus 1 is 1,000. So this is going to be 40. And I'm going to divide both sides by 40. So the square root of Q plus 1 is going to equal to, that cancels that, 2 left over, so 25. Now, in order to get rid of a square root, I just square both sides. That gives me Q plus 1 equal, I believe that's 625. Isn't 25 squared 625?
Yes.
Subtract 1. And we know now Q is 624. So I can put that up here. Q is 624. So now I have P and Q, and I need dQ dP. So now I have to differentiate this function here in this form. I'll call that 2. And let's see how we do that. It looks like we're going to have to do it implicitly. So I hope everybody has this.
Let me give a quick overview here.
There's a quick overview of what I did to find Q. Always use the original equation. I just substituted what I knew at P, and I solved for Q, which is 624. All right. You can always rerun this if you've missed it. Now I need dQ dP. So I'm going to take dQ dP, ddP of this. P plus 1, Q plus 1 to the 1/2. I'm going to bring the 1,000 over to this side. And I'm going to be 0 on the right. Okay, I know this is the derivative of a constant, so that's 0. This is a product rule. So I'm going to put the product rule, P plus 1, the derivative with respect to P, Q plus 1 to the 1/2, plus Q plus 1 to the 1/2, the derivative, the derivative with respect to P plus 1, and that's going to equal 0. Now let's see what we can do here. Well, here we have P plus 1. That stays the way it is. Now this says I have to take the derivative of a function of Q with respect to P. I can't do that. I have to take it with respect to Q. So that's what I do. I say, oh, okay, let's take it with respect to Q. So these two match. This and these, if there's a P here, there must be a P there. If there isn't, you got to change it to a P. If there's a Q here, there must be a Q there. So it's going to be Q plus 1 to the 1/2. But now because I put this thing in there, I'm going to have to balance it by putting a dq dp there, which is actually what I want to find. But now this doesn't change anything because actually dq is in the numerator, dq is in the denominator. I haven't done anything. I actually cancel, but it does change the way I solved this problem. Now the second term is Q plus 1 to the 1/2. Now here's a P and a P. I can do that. The derivative of dP plus 1 is going to be just simply 1. Derivative of P is 1. Derivative of 1 is 0. So that's simply 1, and that equals 0. Now here I have a chain rule. Okay, well, let's just do the chain rule. All right. Chain rule says take the number out here, which is 1. Take the power, multiply by what's in front of that, and that's 1. Take the Q plus 1, subtract 1 from that, and take the derivative, multiply it by the derivative of Q plus 1, which is simply 1. We're going to put here plus Q plus 1 to the 1/2 equals 0. Well, now what I forgot to do is put on the dq dp. Don't forget that, because that's part of this function. So this is what I have so far. Let's clean it up a little bit. Let's go back to here. And we're going to have P plus 1, 1/2, Q plus 1, 1/2 minus 1 is minus 1/2. We'll make that a little better. dq dp. Let's put this back up here. P equals 39 and Q equals 624. Let's get rid of this. Okay, that's going to be plus Q plus 1 to the 1/2 equals 0. Now let's bring this over there and bring the 1/2 in front of this. 1/2 P plus 1, Q plus 1 to the minus 1/2, dq dp now becomes, we bring this over there, minus Q plus 1 to the 1/2. Now, what do I have to do? I have to solve for dq dp. So I divide both sides by 1/2 P plus 1, Q plus 1 to the minus 1/2. Same thing here. And now dq dp, this cancels. Minus Q plus 1 to the 1/2. 1/2 P plus 1. Q plus 1 to the minus 1/2. Now I can do something to make this a lot easier. I don't right now, but if I want, I could bring the Q plus 1 to the minus 1/2 up here, and that would give me minus Q plus 1 to the 1/2. When I bring the minus 1/2 up, I change its power. Q plus 1 to the 1/2 over 1/2 P plus 1. Now, when I multiply, add, what's 1/2 plus 1/2? That's 1. So this comes out to something a little bit easier. equals minus q plus 1 to the 1. And I'm going to bring, if I divide 1 by 1/2, the 2 will come up here. Here. Minus, trying to make it bigger. Q plus 1 over P plus 1. That's a lot easier to handle. But now what do I need? In my elasticity formula, I need Q and P, which I have, but I got to put now what Q and P is in here. So let's figure out dQ, dP in terms of a number. So it's minus 2. Q is 624 plus 1. And P is 39 plus 1. So that's minus 2 times 625 over 40. Now, I haven't done that out yet. If I can find my calculator, I will do it for you. I solved it to this point, but I didn't go any further.
31 point something.
Yeah. Going to be minus 31.3. So now I have everything. I have P, Q, and dQ, dP. So let's go back to our elasticity equation, where N equals minus P over Q, dQ, dP. All right, so this is going to be minus 39 over 624 times minus 37.3.
31.3.
31.3?
Yeah, it was 31.
Yeah. Sorry, my ones sometimes look like 7s. Okay, 31.3. Now let's do that out and see what we get. Now 1.95. Okay, that's greater than 1. So this is elastic. And that's all I would want for your problem. Just tell me what it is. I might ask you to tell me what elastic means in terms of increased price and increased demand, but that's about it. Does anybody else have any other questions that they want from the homework? Because otherwise I will continue doing some possible test problems. Anybody asking?
I don't see anything. Let me check Google Hangout. Let's see if anybody's on there. I don't see anything there.
Okay.
Everybody's on the chat here for the video. So.
Okay, let's do another one. Possible test problem. All right, so let's take this problem here. Have 5x squared plus, that's be f of x, plus 2x plus 1 divided by 2x minus 2 times x plus 1. What did you do? Stop until I did this.
I'm just trying to play around with the lighting to get the,
okay.
The shadows are kind of unfortunate.
There's a lot of shadows here with this, which we don't have when we YouTube. All right, so he just want to find all horizontal and vertical asymptotes. So to find the vertical asymptotes, we have to set the denominator equal to 0. But I'm going to expand this. Whenever you have this, you're in an asymptote problem, you should always expand it. So I'm going to FOIL it. And that's going to give me 2x squared minus 2x plus 8x. We're going to be plus 6x and minus 8. So this is going to help me with my horizontal. So let's look at the horizontal first, and we'll go back to the vertical. The horizontal asymptotes. Okay, it says this is n and this is m. The power of the first term. So here we have n equals m equals 2, which means that the horizontal asymptote is going to be what we say the coefficient in front of the power and the coefficient in front of the other power. So we look at the two highest powers, and it says do 5 over 2. So your horizontal asymptote is going to be 5 over 2. Now, what about the vertical asymptote? The vertical asymptote is actually easier found by looking at the denominator. Now, if x is minus 4, what happens to the denominator? We said x minus 4 equals 0, and x plus 4 equals 0, and x equals minus 4. What happens to 4 minus 4? Minus 4 plus 4 becomes 0, right? That means the denominator is 0. This would blow up to infinity. So that would be, this is a vertical asymptote. But what about the other one? I have 2x minus 2 equals 0. So 2x is going to equal to 2, and x is going to equal to 1. When x is 1, I have 2 times 1 minus 2, and that equals 0 also. So I have x equals 1 as another vertical asymptote. So here I have two vertical asymptotes, x equals minus 4 and x equal 1, which is why you got to keep this here. Now, what you could have done if you wanted to do this one, you would set it equal to 0, and that would give you these two values. So here you have two values for your vertical asymptotes, x equal 1. That causes this to be 0, causes the denominator to be 0, goes to an asymptote towards infinity. X equal minus 4 causes this term to be 0, causes the denominator to be 0, and you get your vertical, another vertical. So you have two vertical asymptotes and one horizontal asymptote. So this one you got 3 answers. Be careful, you might get 1 on the test like that. Okay. Let's go on and take problem like this. So remember, it's very possible to have 2, 3 vertical asymptotes, only one horizontal asymptote given to our rules here, but it's possible. Most you'll have is 2. If you graph it, you'll find that there'll be lines at x equal 1, vertical lines at x equal 1, vertical line at x equal minus 4, and a horizontal line at y equal 5/2, and they'll be approaching those, but never reaching them. So let's go on to another one. That's a possible test problem.
Let's try a little bit bigger.
Okay. So let's take another one. Let's say r of x, or r of t in this case, equals 60t squared.
Oh, there you go.
Divided by t squared plus 50. T is greater than or equal to 0, and that is time. Okay, let me see what I asked here. It's a very similar problem. And what I'm asking here is to find the critical points. Okay, and find if the critical points are at max min. Well, if this is a quotient rule, so A is find critical points, find all critical points, and now we know that the critical points are those at max or minimum. And 2, find which critical points are at a maximum or a minimum. Since this is profit, you would want them at a revenue, you want it at a maximum. So the first thing is find the first derivative. Remember, critical points, first derivative. So dr dt this is the quotient rule. It's the bottom times the derivative of the top Let me erase this and give myself some more room here. Start back here. dr dt equals the bottom times the derivative with respect to t of the top minus, I put a bracket here because of the minus, the top times the derivative of the bottom. 50. And don't forget t squared plus 50. And don't forget, you got to divide by the bottom squared. All right, let's do what they tell me to do here. T squared plus 50 remains the same. It's my writing. I have trouble with those zeros. Okay, the derivative of this is 120t minus 60t squared remains. The derivative of t squared plus 50 is simply 2t. And the whole thing is divided by t plus 50 squared.
T squared plus 50.
T squared plus 50 squared. Okay, let's clean it up a little bit. Let's go back up here. And we're going to get r prime of t equals 120 t cubed okay, well, what's 120 times 50? That would be 6,000?
Yes.
Yeah, 6,000 plus 6,000 t. Okay, minus, here we have 60 times 2t, which is going to be 120 t cubed.
Divided by t.
Divided by, I don't need this here because I already did that.
You distributed it, yeah.
I distributed it. Okay, divided by t squared plus 50 cubed. Fourth. There's no cube there. All right.
Just squared.
Oh, it's squared, right. You're right. It wasn't squared in the beginning. All right, let's try to clean this up. Notice what happens to the 120s. They cancel. 120 t third minus 120 t third. Goodbye. This is 6,000 t over t squared plus 50 squared. Now, in order to solve for the critical points, we have to set this equal to 0. which comes up with an interesting solution. I'm going to multiply both sides by t squared plus 50 squared. Notice that cancels. That's 0. I get 6,000 t equals 0. Divided by 6,000, t is 0. So this says that somehow I make my maximum revenue when t equals 0. Is it realistic? Probably not, but that's the answer we got. Now, this is a critical point. Now we want to find out, is this at a max or a min? So I have two things. I can either take the second derivative of this, which is a long process, or I can use the first derivative, sign test. That means I draw a line. I put 0 here. I go to the left, minus 1, right 1, and I find the first derivative at that point. So p prime at minus 1, this is your first derivative, is going to be 6,000 times minus 1 over t squared minus 1 plus 1. So again, you get 51 squared. So this is going to be a negative, isn't it? No matter what it is, this is going to be a negative. I mean, you can solve it, but this is going to be a negative. That's going to be less than 0. So what about p prime at 1? Okay, well, that's going to be 6,000. 1. Same thing, 51. So that's going to be positive. That's greater than 0. So you got less than 0, p prime minus 1 is less than 0, and p prime 1 is greater than 0. Now what's happening here? You got minus here and plus here. Are we going up or down? We're going down. What does that tell you? That tells me t equals 0 is a minimum point. It says t equals 0 is a point where the revenue, that makes sense, right? Because of this, we were unable to determine whether we have a maximum point or not. What we then would want to do, which you don't have to do for this problem, is to graph it. Graph the problem itself and see if you actually come up with a maximum point. With a maximum point. The problem with this one is that you're probably going to get some inflection points and not any max points here. So this is all you would have to do for the problem. So what would you say here? The critical point is t equals 0. When I test it, it gives me a minimum. There is no maximum point that I can detect from using this technique. And that would be the answer. Okay? And you'll have something close to this on the test. I'm not sure if the answer comes out the same. Let's see if I can conjure up anything else here. I'm actually looking through your exam and trying to get examples that are similar to the ones on the exam, but not exact. And I'm going to have one more for you. Okay. And the one I have for you is this. Let's say you have a company and its costs are given as, let's say, 100 minus 200 e to the 0.1x. Now it's price per unit is given as 500 minus 120, the log, natural log of x minus 5 over x. What do you want to find here? Okay. A, find the revenue. Well, we know that revenue is the price times x. So I'm simply going to take 500 minus 120 log of x minus 5 over x and multiply times x. So the revenue gives me 500x minus 120, the log of x minus 5. So now I have the revenue and I have the costs, and I want to find the profit. So the profit is the next thing, is the revenue minus the costs. So the profit is going to be 500x minus 120 log of x minus 5 minus the costs. And the cost is going to be 100 minus 200 e to the 0.1x. Okay, so I can distribute that, and P of x becomes 500x minus 120 log of x minus 5 minus 100 minus plus minus times minus plus 200 e to the 0.1x. Now nothing cancels. I got to take the derivative of this. It wants the marginal profit. So C, it wants me to find the marginal profit, which is the derivative, the first derivative. So let's take the profit derivative. That's going to be d dx of 500x. I'm going to do each one separately here. Minus d dx of 120 log x minus 5 minus d dx of 100 plus d dx of 200 e to the 0.1x. Now let's take each one individually to see what the derivative is. First one's easy. It's just 500. So P prime of x equals 500. Now we have the derivative of, so we got this term, 120 log of x minus 5. Okay, well, let's look at the log rule for derivatives. So let's erase this, since I already have this. And we have to look at the log rules. Put it on the side here. So one, if y equals a natural log of x, then dy dx is going to equal to a over, well, the natural log of u. Let's call it u. A over u du dx. That's the log formula. But I also have an exponential here. So 2, if y equals a e to the u, then dy dx equals a e to the u du dx. So those are our two log rules. One is the exponential, one is the log rule. So let's figure out the second term here. So I'm going to call this the first term, the second term, the third term, and the fourth term. So we already did the first term here. So the second term, d dx 120 natural log of x minus 5. Okay, here we have a equals 120, u equals x minus 5, and du dx equals 1. Go into the log rule. Therefore, dy dx equals what it says there, 120 over u, x minus 5 times the derivative, which is 1. So I can add on to here. And once again, I'm going to bring this back further. Now 500 minus the derivative, which is 120 over x minus 5. The derivative of the third term is 0. And now let's look at the fourth term. The fourth term is, I'm going to erase this now because I don't need it. The fourth term is a derivative of 200 e to the 0.1 t, or x, right? X. No t's in here. All right. If I follow this rule over here, a equals 200. U is going to be equal to what's in the exponential. So du dx is simply going to equal 0.1. So let's go into this equation here now and just find the derivative. That's 200. It says the exponential, e to the 0.1x times 0.1. Okay? 0.1 times 200 is 20, right? That's 20 e to the 0.1x. And that was called term 3. So let's put that in there. Term 3 was term 4, because I got rid of that's term 4.
Yeah, term 3 was 0.
Term 3 was 0. So term 4 is going to be equal to positive 20 e to the 0.1x. That gives you your derivative. Different derivative than before, right? Okay, let's see what we can do with it. Let's erase this. Now we want to find the C, or D, I believe. Find the critical points. All right, so what do we do with this? Well, actually, this is kind of tough to find critical points. So what I'm going to do is, on my exam, I'm just going to ask you to find the profit function, which we found, find the marginal profit function, which we found. And the last part that I'm going to ask you to do is find the marginal profit function at x equal 2. So all you would have to do is P prime 2 would be 500 minus 120, 2 minus 5, plus 20, e to the 0.1 times 2. Now, once you found that, I'm not going to finish it up. Then I want to ask you how to interpret this. Okay, interpret that. All right, that's pretty easy. Well, what does the marginal revenue, a marginal profit mean? I believe that's I've given you pretty much everything that's in the exam, but there is one left over that I want to go over, and this is something like what's on the exam, a little bit more, a little bit less, well, about the same degree of difficulty. So let's do this one, and this will be the last one. And what time is it, Greg?
It is 10 minutes till 2.
Oh, I did go a little bit over. So let's do one more if you're still with me. Otherwise, you could watch it at another time. I'm given FT, FX, change the T to an X to make it 8x plus 3 squared, x third minus 4x. And I want to find the derivative with respect to x. Okay, this is probably the hardest one on the exam, something like this. But this is a product rule. So df dx would be equal to 8x plus 3 squared.
Do we need this anymore? Maybe we can make some extra space.
We don't need this.
So
no.
we can write a little bit bigger with some extra space, maybe.
Okay. So we don't need that anymore. Here we go. I'll erase it. Okay, so we can increase the size of our letters here. 8x plus 3, the whole thing squared. This should be the whole thing squared. That's right.
You got it.
All right, times the derivative of x3 minus 4x cubed plus x3 minus 4x cubed, the derivative of 8x plus 3 squared. So this stays the same. And what's this? This is a chain rule, right? What's the chain rule derivative? It says the derivative, chain rule, is a n u n minus 1 du dx. So what do we have here? Here a is 1. U is going to be x third. I'm sorry, I should write bigger here. I'm going to bring this down here. 8x plus 3 squared. So this is going to be a equals 1, n equals 3, u equals x third, u equals x third minus 4x, and du dx equals 3x squared minus 4. And let's look at this one over here. This stays the same, but this is a chain rule too. This is a chain rule. This is a chain rule. A is 1, n is 2, u equals 8x plus 3, and du dx equals 8. So now all I have to do is substitute these in here. So this is going to be multiplied by, says a is 1, n is 3, u is x third minus 4x, and I'm going to take 3 minus 1 times du dx. Now this one here is going to be x third minus 4x. And here we say a is 1, n is 2, u is 8x plus 3. That's going to be 2 minus 1. And the derivative is 8.
Yeah, close bracket there.
Okay, let's clean it up. Now we got everything that we need here. So let's clean it up. And I think I will probably stop there. But this is f prime of x equals. Okay, 8x plus 3. Well, I might do one more if you're still around. 3 times 3x squared minus 4. I'm going to do 3. I'm going to move this to here. Commutation rule. 3x squared minus 4. And x third minus 4x squared, right? Now down here we have plus x third minus 4x. And here we clean this up. 2 times 8 is 16. Going to be 16 times 8x plus 3. Now let's see if there's anything I can factor out here. I can actually factor out 2 things to make this a little bit easier. First, I can factor out factor 8x plus 3. So let's put that out here. That's going to give me 8x plus 3. Okay, bring the 3 here. This 3 goes out here. 3x squared minus 4. X third. Minus 4x squared. Now plus x third minus 4x times 16. And the 8x plus 3 is out here. That's it. Now, what else could I factor out? What else could I factor out? Well, I can factor out an x third minus 4x too, right? I have an x third minus 4x squared. So I can factor out 8x plus 3 x third minus 4x.
Oh, actually, you do need to bracket here and here because you factored out 8x plus.
That's why I put that.
But you need another one out here too because this closes that, doesn't it? Oh no, I'm sorry.
No, you don't really need that.
I'm sorry.
Yeah,
I'm tired.
You didn't need it. I was wondering why. You want to add brackets? Feel free.
Sorry, everybody.
Okay. So I'm going to multiply. Taking out the x third plus 4x, and that's giving me 3, 8x plus 3, 3x squared minus 4, x third minus 4x plus 16. And actually, the factoring out doesn't help you too much in this case, because the next case would be find f, at x equal 10, f prime. So you really don't have to do that. You can actually keep this in this case because factoring doesn't help you that much. You still have 3 terms here. I would keep this in this case, and just wherever you see x, put in 10. Okay? And I know it's a bit, it's a much in arithmetic, but once you start to combine these, it becomes a simpler problem. Factoring doesn't really help you here. Okay. So, although we tried factoring, it didn't give us anything much simpler. So go back here, find f prime 10, and that's all. And I believe I've covered everything which looks like what's on the test. Now, if you have any questions from your homework, I'll spend 10 more minutes. This is a little bit over time taking your questions. Is anybody left?
We have a few people left, and the comment stream is kind of dried up, it looks like. So I don't think anybody's commenting.
Okay.
Well, and again, office hours tomorrow at...
office hours tomorrow, 11:30 to 3:30. You'll be getting the exam late tonight.
Yeah, Google Hangout, office hours.
Google Hangout, office hours. We actually are using this whiteboard, which makes it really a lot easier, and it's a lot easier to see on Google Hangout than it is on here.
Yeah, we're doing the best we can with what we have. So I think we learned a lot from this. Maybe if there's another review you'll do, we'll...
if there's a review for the final, we're probably going to do it a different way.
Make some improvements, yes.
Yeah. Okay. But anyway, thanks for attending. And you'll be getting your test number 2 tonight. Okay? Okay, bye. Yeah, that was a little tough.
All right. Time out.
That was tough.